And we're live. Hello, everyone. Welcome to today's AMA. It's going to be a fun one. We're talking about a new book that has been launched just a couple of weeks ago called TinyML Cookbook. And we have the opportunity to actually not just speak to the author of the TinyML Cookbook, but also to Massimo Banzi from Arduino and Alistair Allen from Raspberry Pi. So we've got a really packed session. It's going to be an exciting one. Feel free, as usual, to ask all questions on the chat. We'll make sure to pick them up as they come. And without further ado, I just want to introduce to you all the speakers. So let's start with the author of the book. So Gian Marco Iodice, tech lead from the ML software team at ARM, and also author of the TinyML Cookbook. We then have Massimo Banzi, co-founder of Arduino. Welcome, Massimo. And we have Alistair Allen, head of documentation at Raspberry Pi. Welcome all. Thank you so much for joining us today. I'm excited to have the chance to talk to all of you. I think it's going to be an interesting conversation around the past, present, and future of TinyML, and really interesting to hear from you guys what you think. So without kind of delaying too much the introductions, given that you're all famous in your own rights, I'm just going to skip through the introduction and actually kind of jump right in. So I'm curious about getting your thoughts on what does TinyML mean to you. So let's start with the author of the book. So Gian Marco, take it away. What does TinyML mean to you?
Well, for me, TinyML, well, first of all, hi, everyone. So it's definitely a great pleasure to be here. So thanks, Eben, for hosting this session. So for me, TinyML is the joint effort between ML and embedded systems to allow or to make battery power applications smart. This is definitely what I think. And definitely, this is a unique intersection. I'm saying this word because I have been lucky enough to work at ARM since the beginning of my career on ML or with ML on edge devices. And what we have here is completely different. It's not just ML. This is ML plus embedded system, because if these words, they don't know each other at best, we cannot have any machine learning applications on it. Well, for me, actually, instead of explaining what it means for me, I'd like to use an example. TinyML, for me, is the way to make something that is currently difficult to achieve. I can give an example with, let's say, with a water leak detector, for instance. Water leak detector is a smart device, right? But if we detect the water, it means there is already a damage, right? Would it be much better if we could predict the fault, right? And that is what I see TinyML playing a significant role. So trying to predict fault to prevent damages. So this is just one of the area where I see TinyML playing an important role.
Thank you, Gian Marco. Thank you for that insight. Massimo, you're next up. What does TinyML mean to you?
Well, to me, it's a very interesting opportunity to increase in a way the smartness of small devices. So we mostly make small devices that are designed often to be powered by batteries, and the ability to use these algorithms on these kind of devices unlocks a lot of possibilities. And also for me, there are maybe sometimes less obvious things that I really like about this. The fact that you run this machine learning localized inside a device has an advantage on the privacy side. So, not sending data around, but also, optimizing just enough compute. So we talk a lot about sustainability, and then we put massive computers to process three sensors. So in a way, this idea that we can really just place just enough compute with just enough computing power and make it also conserve bandwidth and be privacy conscious, I think are values that are important and interesting, and new tools for people who build embedded projects.
Awesome. Thank you, Massimo. And Alistair, last one up, but not the least. So go on. What's your view on TinyML, and
So
what does it mean to
for
you?
me, I think TinyML is all about machine learning eating software. It's about allowing us to add abstraction into the physical world, allowing us to take legacy sensors and legacy actuators and try and layer a level of smartness, a level of computing on top of that in a very simplistic way that means you don't have to be intrusive in, say, a large multi-million-pound machine or a network of gas meters or something that's been installed out in the world for decades. It's a way to allow us to layer the internet, to layer cloud connection for a start, or just smartness, even distributed smartness into the world in a minimally intrusive way. I think for me that's what it's about. It's about also privacy, and Massimo mentioned that, which is if you can take the internet away, you can deal with the data you're taking right there at the edge. You don't have to generate large amounts of data and stuff it up into the cloud and then inevitably leak it onto the dark web. So I think for me, it's about smartness right there where it's needed, and privacy for both individuals and companies.
Awesome. Thank you for that. I think you guys have given a great introduction to TinyML and a great few insights on what you think is important around this interesting topic. We're here to kind of celebrate the launch of a new book and also talk about some of the details and where it goes, what it does, why this new book on TinyML. We've kind of covered a little bit some of the opportunities. We've listed some of the opportunities that we all see around TinyML. I think I'm interested now in hearing from Gian Marco what brought you to writing a book about TinyML.
Well, Alessandro, definitely I wanted to contribute to TinyML and how I wanted to help people entering this amazing world. Because I believe, now it's pretty famous TinyML, right? But since it is the intersection between ML and embedded system, you need to know these words, right, to have efficient TinyML applications. So therefore, I decided to write this book primarily for people with no embedded programming experience to learn and discover what machine learning means on microcontrollers. Definitely, the book is also beneficial for people with embedded programming experience, but they need at least a basic understanding of what machine learning is to read or learn the projects reported in the book. But definitely that is the main motivation. So helping people with no embedded programming experience to enter the world of TinyML.
Awesome. And you come from the ARM world, right? So a world of hardware and hardware architecture. So as I do, actually, we were colleagues back a few months ago, actually, not too long ago. But a question that came from the audience, I think you can address quite well in the context of TinyML. The question is from Mark, and he's asking, is the learning done on chip, or must you use a bigger computer to build a model and then dump the model on the device? I think, let's address the question of what is TinyML, right? And like, at a very high level, and what's the difference between training and inference, I guess, right? And
Okay.
I'll leave that to you.
Absolutely. So here we're talking about machine learning, but we talk about inference. So just inference on microcontrollers. I would say that most of the time you train your model in the cloud. You have your model, which requires to be quantized to run efficiently on your microcontrollers, and you run the machine learning inference on these tiny devices. And say before I mentioned quantized, because these models are definitely power efficient, but in order to be power efficient, then they don't have the computational capabilities that we may find on a smartphone or a desktop machine. And most of the time do not have floating point acceleration as well. So that is the reason that this model will need to be really small, quantized, which means with integer computation, in order to run on these tiny devices with few megabytes probably of hard drive or program memory, as we used to refer here, and very little, a few kilobytes or few hundred of kilobytes of RAM.
Awesome. Cool. Okay, so I think we've covered what TinyML is. We've covered your views on TinyML, at least kind of an introduction to the views that you have on TinyML. What is you've got? I've read the book. There's a lot of recipes, right? Like the approach you take is really the kind of practical approach of walking people through the step-by-step process that it requires to build, that you require to build an application. A machine learning application on a tiny device. Now, it's interesting, right? Because in your book, you use both Arduino and Raspberry Pi for different recipes. So I'm kind of curious, maybe if you could share with us a couple of recipes that you think are important, I guess, or interesting for the audience to kind of look forward to.
Well, definitely. I can tell you, and I can tell to the audience, the recipes I really enjoyed writing, definitely, which were chapter 5 concerning the indoor scene recognition. So in short, you write a machine learning model for recognizing indoor environments. This could be applied, for instance, for a robot, for moving around a house, for instance. And this has been deployed on the Arduino Nano with a camera model and using transfer learning. The thing I really enjoyed writing when writing this chapter is the part, is not necessarily the part related to machine learning, but on the data preparation. Because there you have a camera module with a fixed camera, with a fixed frame resolution and a fixed color format. And try to guess, well, the input of your model is completely different. You have a different resolution and you have a different data type. Therefore, you need to convert this camera frame to the input of the model in a most efficient way. With most efficient way here, I mean in a most memory efficient way, because you don't want to waste resources. And I really enjoyed explaining how to do the fusion of different operations involved, which are the scaling, for instance, the color conversion, the cropping, the quantization, normalizations, all together in order to explain, well, machine learning is a problem, but definitely before machine learning, you need to keep in mind that all the operations involved are still important in order to have a working application. The other thing I enjoyed writing was on the Raspberry Pi Pico, implementing a smart remote. So in that case, using Edge Impulse, the project aims to build this remote for controlling the YouTube playback. So you have videos and you use your Raspberry Pi Pico to play, pause, mute, unmute the playback on YouTube. And that was nice because in that specific recipe project, I could also explain that, well, although we don't talk a lot now about feature extraction, because, well, we talk about convolutional neural network, there are still cases where feature extraction is still important because it makes your machine learning algorithm really efficient from a computational and memory perspective. I think these are the two main ones. There is actually a third one, if I can, which is one which is not based on Arduino and Raspberry Pi, but on a virtual platform. A platform that I used for the first time 8 years ago. I decided to use that one to demonstrate that actually TinyML could be possible also 8 years ago. The thing now is we have much more knowledge about machine learning, new algorithms, and it's possible to run on a very old platform. An image recognition, in that case, is CIFAR10 on just 64 kilobytes of RAM. And really enjoy also writing that chapter number 7, actually.
Cool. Thank you, Gian Marco. Okay, now you've talked about feature extraction, right? You've kind of alluded to the fact that machine learning, TinyML is much more than just machine learning, right? I'm actually curious to hear Alistair's and Massimo's thoughts on this, because I know that we've talked about this with both of you. I've talked to both of you about the importance of like the different aspects and the DSP feature extraction stage, and how much that plays a role in the TinyML world, right? So I'm actually curious to hear your thoughts and more maybe around like what has changed, right? Like I think a few years ago we used to do DSP on microcontrollers. We still do DSP on microcontrollers, but now we also do ML. So what is really different here? Who wants to start with the importance of feature extraction in the TinyML space? Massimo, Alistair?
I can go if you want.
Yeah.
Now, since I went first last time, I was leaving space for Alistair. But yeah, no, totally. It is actually a very interesting part of the process. We because I was reminded that we have this thing which is like is the Nano BLE Sense plus a camera, and we built this for a class for a class on machine learning. And obviously you have this camera which is very, very simple, and being able to get the information and process it and structure it in a way that's optimized for an algorithm running on a very small microcontroller is actually a very interesting challenge for an engineer, for a nerd. And I think that's obviously one of the interesting things. I don't know for also because in a way, some of the software that we run on this thing sometimes is software that was designed to run on a desktop PC and was kind of adapted to run on, there's a bunch of TensorFlow code that was written for the regular TensorFlow running on a computer. So if you don't do anything optimized, that doesn't really matter. But when you transfer that over to these processors here, you have to rethink a lot that part of extracting the feature, processing the data in a way that's optimized for these little devices. So I don't know. It's an interesting challenge. I don't know how deep you want me to.
No. I mean, I think that's exactly it, right? Like the tools are the same. The kind of the things that we used to do are still valid. It's not like we're throwing away stuff that DSP signal processing that we used to do a few years ago. We're still using all of that. It's just that now we're using more stuff, right? That's kind of what I wanted to get to. It's just additional pieces, additional blocks than the ones that we used to use. But I mean, Massimo, you guys have enabled with Arduino really that you've given everyone the ability to really simply code things for a microcontroller, right? And now it's just coding more or slightly in a different way, but still the same type of coding, right?
It's a different way of doing code, and on one hand, there's also there's still quite a big gap on how to teach people how to do this. So, sorry.
I mean, I think for me, the last couple of years, well, I mean, I guess coming on 3, 4, 5 now, is the importance of quantization really is the thing that's changed machine learning over the last 5 years or so. It's enabled TinyML to go from, a Raspberry Pi 4 level ARM down to Cortex M0 plus type level. That's what made TinyML really tiny, is quantization. I mean, I think 5 years ago, we didn't really understand as well as we do now that quantization was important, that you could still get good results from models once they were quantized. People were still doing very, very large models. And the understanding that you could reduce the model size down so much to fit in these much smaller devices wasn't really there. So I think the thing that's changed to enable things is quantization, and the importance of quantization in TinyML cannot be overstated, I don't think.
Absolutely. I think Gian Marco also mentioned quantization earlier, right? It is an important tool that we have to actually enable these things. But I mean, talking of Raspberry Pi, it's quite interesting that we have models, machine learning models, real machine learning models running on an M0, right? And that's something that I think, Alistair, I remember our first conversations about TinyML or even just ML on microcontrollers a few years ago. I don't think neither of us would have thought that this was going to be possible in just a couple of years, right? It's quite interesting how far we've gone.
No, it's totally. We were. I mean, so when we first started discussing this, 5 years ago, I think, we sort of started kicking around ideas for this. When we first started discussing it, it was very much like, can we get a Raspberry Pi 3 to run a machine learning model? And we weren't sure. That was the sort of level we were at. And the fact that Raspberry Pi Pico, the RP2040, which is in a dual core Cortex M0 Plus, which is, it's not a very powerful chip. There are some interesting aspects to RP2040 that makes it interesting, but for ML, but it's not a powerful core. The fact you can run machine learning on that at all, inferencing at reasonable speeds, is pretty surprising.
Yeah, we've got some people excited about the TinyML Cookbook, Raspberry Pi, Arduino, Edge Impulse. So awesome. Thank you, John. And thank you, Alistair. Cool. So going back to the book, I've got one last question about the book. I mean, I have to ask this question. What role does Edge Impulse play in what you've done in the book? I mean, how much does Edge Impulse play a role here?
Okay. Well, Edge Impulse plays an important role in the book. First, because the book is a snapshot of the present, past tools. Because, TinyML is under heavy development. There are still interesting tools under development. I'm pretty sure in the next year will be extremely important. And Edge Impulse represent an important tool for TinyML and the book to explain how to deploy machine learning application easily. Because the book will use primarily two tools. One is TensorFlow Lite for microcontrollers. The other one is Edge Impulse. And Edge Impulse wants to show a different workflow and show how we can make machine learning applications of microcontroller extremely easy, from the data acquisition to the machine learning deployment. Because that is the thing I really enjoyed, is the fact that how Edge Impulse actually makes the data acquisition extremely easy, even if you don't have an unsupported platform. For instance, Raspberry Pi Pico, when I wrote the book, was unsupported, but now is supported. But I could use the data forwarder quite easily with the tool, and I could acquire, with just a few lines of code, anything through the serial to the serial. So that is the reason why Edge Impulse plays an important role for the book. There are two projects. So one is about keyword spotting, which is for both Arduino Nano 33BLE Sense and Raspberry Pi Pico. And the other one is just on Raspberry Pi Pico, which is the gesture recognition, or better, the smart remote for controlling the YouTube playback. Sorry.
Awesome. Cool. Well, thank you for that. Perfect. So I think we've talked about TinyML. We've talked about the book and the interesting things. We've kind of touched on the platforms that you use. So we mentioned that you use both the Arduino Nano 33BLE Sense and the Raspberry Pi Pico. You also mentioned that things are evolving really fast. So I'll be asking both Massimo and Alistair in a few seconds what else has come out, because I think there's new boards that are out since, at least on the Arduino side, I'm sure. But before that, actually, I wanted to kind of maybe just recognize the importance that these two boards have in the TinyML space, right? I think most of these boards, most of the people starting with TinyML actually are using one of these two boards, right? I think it's quite exciting and it's quite interesting how much these two devices have actually opened the doors to TinyML becoming really a thing in all over the space, right? And I think the question I've got I'll start with Massimo. What makes this particular board, so the Arduino Nano 33BLE Sense, kind of the right board for TinyML, right? Like, what makes it special in your view?
Well, when we started working on the product, the general idea at the beginning was to build something that would have like a ton of sensors on board, because there was more and more the perception that people wanted something they would have so many sensors already packaged on the board that you could use it straight away without having to build any electronics. And also, the processor is a Cortex M4. The clock speed is not incredible, but one of the interesting things is that, as we know, the Cortex M4 has a number of features and instructions that speed up a certain type of DSP applications. So in a way, there was this perception that combining a processor with some of those features, the fact that it has Bluetooth and the fact that it has all the sensor on board, could be an interesting platform for a number of applications. Then, in a way, during that time, TinyML started to kind of become something that people talk about. And so we tried to kind of, go and talk to a number of people who do TinyML and tell them, hey, why don't you, we sort of encourage people to start using it as a platform, and it's been working quite well because a lot of the TinyML platforms tend to support this hardware. So it was and now there's more space for doing similar kind of projects.
Yeah, and I think there is actually a kit that you've done for Harvard as well. That was one of the first TinyML kits. Or was that? Oh, is that the actual kit? Okay, cool. That's perfect.
Sure. Yeah. So this is part of that kind of, they started to use it. First of all, it was adopted by TensorFlow as one of the reference platforms, and then through that process, a number of people who were using TensorFlow Lite Micro as their engine started to also adopt this board.
Awesome. Thank you. Were you going to add something else, Massimo? No. Okay, cool.
Sorry, I didn't understand what you said because you
No, sorry. I thought you were going to add something else, but you stopped. So
no, if you know me, if you let me go, I can go on forever. I'm trying to contain myself. I'm trying to gesticulate very little and talk as little as possible.
I always love hearing you speak, so it's absolutely a pleasure. Alistair, what is your thought on why the Raspberry Pi Pico has become an important board for TinyML?
So of course, Pico is a very different beast than the NanoSense board. Pico is becoming important because of the RP2040, which of course is our first custom piece of silicon coming out of Raspberry Pi, and the thing RP2040 was designed for, and therefore Raspberry Pi Pico was designed for, is flexibility. It's got a very large on-chip memory compared to other sort of similar microcontrollers in the class. Symmetric dual-core processor, deterministic bus fabric, and a very rich peripheral set, and of course programmable I/O, which lets you essentially connect it to things that you couldn't connect to other microcontrollers to. And it wasn't designed initially for TinyML. I mean, designing a piece of custom silicon takes a very long time, and the design process started very much before TinyML was a real thing. But it turns out the things that we wanted to do with it, the things it was designed to do, are also very useful for TinyML. That the large on-chip memory, the ability to wire as much flash memory in as you really want. And of course, it's really cheap. So a Raspberry Pi Pico is $4. So you can integrate it into projects, you can integrate it into products very easily. And I think in volume, I think we're now pushing RP2040 as 70 cents a chip or something like that. So from our point of view, the reason that's taken off in the TinyML world is its flexibility. You can connect it to things that otherwise might be hard to connect to, and price point. They're easy to get a hold of, and they're cheap. And if it didn't do exactly what you want, you can go out and buy a bigger chip that does what you want, and you haven't really lost too much. So people are coming in and using it because they can.
Awesome. Yeah. And, I think one of the first conversations I had with you about TinyML was actually around the fact that, chips were becoming so cheap that you could just kind of stick them somewhere and then just forget about them, or not that you should do that, but just the fact that you have that you can kind of use as many chips as you want and really not have to worry too much about cost, right? Is a huge driver here, because it really unlocks a lot of new possibilities, right?
Yeah, we've talked about this before, haven't we? I sort of call it capable computing that's good enough. And I think that one of the first chips that sort of brought this home to me was the ESP8266, which became sort of an overnight success in the maker community, simply because it was very cheap. You could get it for $2 or $3 a board on AliExpress, and it was very much available. Like the whole tool chain for 8266 was built pretty much by the community, because the chip was available and it was cheap and it had abilities that they could use. It was good enough. This is an argument I've had with a bunch of people, which is like, they have this thing where it's just like, well, eventually, it was something I had an argument with the folks at Intel at one point. And it was like, well, eventually you want to move away from these low boards and buy like an x86 that has all the power and the capability. And it's just like, well, why? If it's good enough and we can get by, then people don't want to deploy heavier weight computing. They want to just use the stuff they're used to and do the job. So we've reached a point where our computing is mature enough that even low-end computing is usually good enough to do the job you want to do. So why waste large amounts of money and large amounts of power using something more heavyweight?
Absolutely agree. And I think we're at the point where we can actually make the most out of these compute platforms, right? I think the reason why I'm really excited about us all working together is because of this, right? Like, I think we are all making it easier in our own rights to deploy, to develop, to even come up with applications for TinyML, but more in general for embedded, right? And I think that's a big plus, right? I think when I started, things were much more complicated, right? Like we've gone a long way, and I think we're now at the point where you can actually deploy easily a machine learning model on any board, effectively, Arduino, Raspberry Pi, and really it's we've kind of removed the complexity from all that and made it really possible for everyone. So that's really exciting.
One of the things I'm sort of looking forward to, and it's not been done as far as I know, and if it has been done, please someone point me at it, is Python doing machine learning on microcontrollers. I mean, especially on something like RP2040, where you've got the dual cores, it should be doable, right? You could do one core running the Python stack, and then the other core with the model on. It should be doable. I mean, and that would sort of lower the barrier to entry to TinyML. You should be able to do that, and then the machine learning folks and the Python folks, the big data folks, can come in and then just use their existing Python code to a certain extent. But yeah, I mean, it's barrier to entry is the thing that's gotten much simpler in the last couple of years. Sorry,
I didn't want to interrupt, but I agree. Without giving too much away, I've got a demo running that's using Python on a microcontroller. It's an Arduino board that I'll talk about it in a minute, but it's actually, I'm going to show it in a few. I mean, I'll let Massimo talk about it because he knows more than I do, but yeah, we'll do that in a minute. But before diving into that, one question that I've got for all of you. So we've talked about, the kind of the breadth of TinyML, like the potential. But one thing that, we get asked a lot is, what use cases is TinyML good for? And actually, someone here mentioned, I think it was John, talking about that. Yeah, here, I'll pull it up. So it is interesting when discussing TinyML with folks from a more traditional ML background. Yes, there are use cases that don't need a powerful system with multiple INC GPUs, right? There's still people that think that ML is all about big GPUs and it's all about the cloud and it's all about, kind of developing these huge models that can do everything in one model. But we all know that it's not just about that. So I'm actually curious to hear your thoughts on what is the kind of what are the main use cases that you're seeing? What are the kind of more exciting use cases that you're hearing about or you're seeing deployed? So I'll start with Gian Marco, and then we'll go around.
Well, the home security for me is one of these because with TinyML, you don't necessarily need internet connection. So this means you may have a smart camera or that basically does the job without internet connection, preserving privacy, avoiding any issues. So that could be an interesting use case for TinyML. Honestly, I'm looking forward to see more on this. So maybe smart cameras that do not require internet connection. I leave Massimo and Alistair to say also their thoughts.
Okay, let's go with Massimo next then.
Well, obviously, I mean, with Arduino lately, we have been concentrating quite a bit on industrial applications and for the work that our pro team does. So we see a number of application in the industrial space and people that we have followed around that. So it covers a lot of crazy things. There's a company that we are working with that is putting essentially sensors and machine learning inside of a bolt. So they built the titanium bolt and they put the machine learning directly in the bolt, which is quite interesting and extreme. But also people who have been building, they replace a basic sensor that are maybe in a piece of equipment with something that has also vision. One example that we saw is a company that is using it to detect if a shampoo bottle has a cap mounted correctly or not. But it's interesting because this can replace an existing sensor that before was just detecting if the bottle was there, and now can also do this extra stuff. But we also see some very interesting. So these are some of the things that we see. Though personally, I like a lot some of the use cases that I've seen where people are using it for detecting illnesses or interesting thing. There was even a project done with Edge Impulse to detect a respiratory illness in pigs, which I think was quite interesting.
Mm-hmm. Yeah, absolutely. Yeah, there's a lot of interesting stuff in the health space, although it's always hard to get the right certifications and things in place to actually deploy, in large scale. But I think we're getting there. We're getting there. Alistair, what are you seeing?
I mean, I think I agree with Massimo. I think the real impact you'll see in the next year or so is going to be in the industrial space. It's where the low hanging fruit is. It's large machine, large production lines where you can sensor up for failure warning for large machines. It's out in the field where you can put things on tractors and then gas meters and stuff, and try and take things that already exist. I mean, I talked about this right at the start, right, which is the machinery and sensors and other such things that already exist in the real world, and we add a level of smarts to it. And that's the real early payoffs for TinyML, because you can layer that smartness into the world very easily. I mean, the classic one is I saw a project, I can't remember where it was, which was reading gas meters. I don't know how your gas meters work in the rest of the world, but in the UK, it's very much a little dials that go around and around and around, and you get a little blinking LED every time the dial goes all the way around, and that's a unit of a therm or whatever it is. And I've seen a whole bunch of projects that like layer light detectors on top of this blinking light, and it goes, but the glue eventually peels off and stuff. So the machine learning, just sticking a camera in front of this and watching it go around, have been a lot more successful and a lot more reliable. And the fact that you can make the camera into the best low-cost sensor is a great win for TinyML. It's like making cameras into sensors, because they interpret the world in the same way that humans do, right? With like the world is very much set up in a visual way, because we look around and we see things and we see readouts, And the fact that we can now put a bit of smartness behind a camera and make that into a sensor to do things when the world changes is remarkable.
Yeah, I think, you mentioned something that we see a lot. There's a lot of need for a lot of companies, enterprises having the need to retrofit kind of old devices, because in a lot of cases, they might not have the time, they might not have the resources, they might not even have the ability to turn off a production line, for example, right? So you might have to like retrofit the production line rather than turning it off and like stopping your production for a few months while you build something new, right? So in a lot of cases, we see use cases where retrofitting an old device, for example, a meter, and reading the meter with a camera is actually a good solution. And it does solve, it does allow you to make that meter into a digital meter, even though effectively you just bolted something on top, right? We see a lot of that, actually. It's a really interesting use case.
I mean, for production lines, not being able to turn them off is actually a benefit for TinyML, right? Because that's your learning data set. The production line is running correctly, so this is your data set for getting correct behavior. So the fact that you can't turn it off is a benefit rather than the stumbling blocks of fitting TinyML.
Absolutely. Cool. So I think we've talked a lot about machine learning and camera and smart cameras. I think both Gian Marco and Alistair brought it up. This was not set up, so but it's a great segue into the demo that I wanted to show you guys. So I think actually, why don't we do that now? So what I'm thinking is, first of all, Massimo, can we talk a bit about? I mentioned it quickly earlier. There are, since the book has come out, there's actually a couple of new boards, right? Can you tell us a bit more about this board that you're showing us?
So I'm trying to figure out a way how to illuminate it properly, but
we see it. Yeah, there you go.
Okay, it should be okay. Yeah, so it's part of a new family of products that are called Nikola, and it's a small square. It's less than an inch inside. It's 23 millimeters, and this particular version is called the Nikola Vision. And it packs quite a lot of features. It's an industrial product mostly, so it's not designed to be a low-cost product. It's designed to be placed inside a piece of equipment, placed into essentially into even environments that would put stress test this thing. But the basic thing is that it's a color camera with a dual-core ARM microcontroller from ST Microelectronics. So it's a Cortex M7 plus a Cortex M4. It's got microphone, it's got time of flight sensors, Wi-Fi, Bluetooth, battery charger. You can run it on a LiPo battery. You can connect it via USB if you want to. So there's a number of use cases for this. And the default version comes out with OpenMV already installed. So you can program it in MicroPython using the OpenMV IDE, or you can program it with the usual Arduino, or you can use the STM32Cube development environment. So there's a number of options, and the fact that it's dual core opens a lot of interesting options for running the more compute intense on the Cortex M7, and then usual. But the idea it's small, battery powered, and you can do a lot of interesting things. And you have good algorithms, Alessandro, but I don't want to spoil your demo.
No, I mean it's a new board. When did it come out, Massimo? I can't remember exactly. Was it a month ago?
Yeah. It's probably even less than a month ago. It's very new, and it's selling quite fast. So also at the moment, building electronics is one of the least fun things you can do in life, because essentially all of the people who make silicon parts are struggling to deliver. And so, this is very, very popular, and our logistics manufacturing team has to just go around the world trying to get all the parts to continue making it. So it's an interesting time. Interesting time. So there's a question, actually. Can I answer the question from the audience about the Nikola?
Yeah, we'll pull it up.
Is the Nikola hardened for reliability? So the Nikola is designed to be an industrial product, so it works at a extended temperature range, and it's also it is certified and is being certified for all the usual certification that sort of more professional and then industrial equipment is certified for. So the ultimate objective is that you can put this thing into a piece of equipment. You can put it into on the field, and it will just work.
Cool. Okay, so we kind of talked about the board. We talked about TinyML. I think what's really exciting, and we've kind of talked about this a little bit as well, the potential, right? The potential of like doing more on these devices. And we've talked here both about the Raspberry Pi Pico that has a dual core M0, a symmetrical core, really powerful. Alistair, you mentioned it's got a lot of RAM on board. We've then talked about the new Nikola Vision that's got a dual core M4, M7. I think they're both interesting boards, obviously, for different use cases. We've got here actually a demo with our latest object detection model running on the Nikola Vision that I wanted to show you. And what's interesting is that you can build this yourself. You go to Edge Impulse and you can build what is called Fomo. And for the ones of you that are familiar with machine learning, there is a famous model called YOLO. And so we thought of renaming this or naming this new model Fomo. But it actually stands for fewer objects, more objects, because what it does, it enables you to detect actually objects on a microcontroller. And this has never been done before. The interesting thing is that it's now possible to actually do object detection on a microcontroller. And the reason why it's more objects is because you can actually look at a lot of objects and detect a lot of objects on the camera frame. So I'll just show you this quickly. We've collected a load of images with different classes. In this case, it's washers and screws. And we've collected a bunch of them. We've auto-labeled the images. So quickly you can collect more images and label them. And then we've deployed this to an OpenMV board. And I'll just show that quickly. So I'm not going to dive too much into the model. Actually, the one thing I'll show you is that the Fomo model can be selected here when you build your model. And actually, you can even go in the Keras mode and look at what the model is, right? So it's not a black box. You can look inside and figure out exactly what it's doing. So you can be confident that it's doing, what you expect it to do effectively. But without kind of diving too much into this, I didn't want to walk through the whole project. But what I wanted to do was show this in action. So let me just share my other camera. Just give me a second. So let me remove this. This is top screen. Too many things to share. Extra camera. Okay, so what I'll show you is now, this is a setup I've got here. So you can see, let me just make this bigger. So you can see here, this is a Nikola Vision here. And I've got these bolts and screws down here. And I'm just going to show you this running. I just need to stop sharing that and share another screen. So the interesting thing about this is it's actually running on an OpenMV. And, Alistair, you were kind of suggesting this earlier. It's actually running MicroPython. So let me just start this and share. Just give me 1 second. Just getting the screen up. There we go. Okay, here we go. So you can see here, this is actually live, right? You could see the different objects that I showed you earlier. And you can actually see that the object is being tracked, as in it's being recognized, but not just recognized. You're actually getting in the left side here in the panel, you actually see the location of all these images. So you can see there are 2 screws. I mean, you can't really see this that much. Let me just zoom in a little bit more. Let's see. Oh no, that doesn't work. I'll just go to this. You can see that there are 2 screws, and it recognizes the X and Y coordinates of those 2 screws, and then it recognizes where the washers are. And what's interesting is that this is happening in real time, and you can see it's about 21 frames per second on this particular demo. And this is running effectively. This is MicroPython, right? So it's we've deployed or we've wrapped a model in MicroPython, and you're running it in OpenMV with MicroPython calls. What's interesting is that you can modify any of this, and it will just kind of change the way it operates, right? Because it's just Python. It's super interesting. I mean, you mentioned, I know that Raspberry Pi Pico also has a MicroPython SDK, and it's super powerful. And I'm really excited about this because it does open up to a whole new class of developers, really. So this is, Massimo, correct me if I'm wrong, but this is Arduino. Obviously, Arduino is supporting OpenMV, and there is a collaboration. So effectively, you can easily kind of pass between the 2 platforms. And it's really easy to also get data into Edge Impulse and out of Edge Impulse into OpenMV and Arduino.
Yeah, we support OpenMV, and so they port their software to our platform, and actually they even ported OpenMV on our Nano RP2040 Connect. So technically, this kind of code could also be running on the Raspberry Pi RP2040. Maybe not at this kind of frame rate, because this is running on a Cortex M7 at 480 megahertz. So, but as a slower, the kit that we made for the students is running at 7 frames per second, and it's useful for basic, computer vision stuff. So there is OpenMV for the Nano RP2040, and
that means it works for all RP2040s at that point, because it's the same code base, I guess.
Yeah, it's the same stuff. It's just probably just a question of the pin mapping, and that's it.
Yeah.
But
awesome.
OpenMV is great, and we are happy that we are working with them.
And what's interesting, Massimo,
this is really cool. This is the first time I've seen this. This is, gonna have to do some Googling now.
Yeah, well, I mean, I can say I'm pretty confident that this will not run on an RP2040 because of the. I mean, this is pretty beefy, right? Like, we're talking about object detection here, so it's a pretty beefy model. We have it running on an M4, so we have it running on an Arduino Nano BLE Sense, 33 BLE Sense. So it does run, obviously, slower frame rate. I'd be surprised if it did run on an M0. Might be, maybe you can prove me wrong, Alistair, but it's quite impressive because effectively we've re-architected the object detection model and made it possible to run it on a microcontroller, right? Because here we're actually using as a base model, we're using MobileNet v2 that we've then re-architected. So it's a pretty beefy model that used to just run on beefier computer platforms. Actually, interestingly enough, we've sped up the running of this on a Raspberry Pi 4 by 20x. Just by just using this model, right? So effectively, it's just a more efficient way of doing object detection. Obviously, it has limitations. It's not perfect in the sense that it's got a couple of like really basic limitations. I'm just going to share just for transparency. It doesn't basically, because it's a grid. It's got a grid and it's able to detect things within a certain square within the grid. It's not able to detect multiple objects within the same grid or the same square in the grid. So that's one limitation. And then the fact that it's able to, it detects very well objects of the same dimension. It's not very good at detecting objects of different dimensions. But beyond that, it does do pretty well at object detection. So it's quite interesting. And yeah, I was keen to share this with you guys. So I'm going to stop sharing my screen. We've had enough of that. And
I'd like to add one thing, Alessandro, because this is a very cool demo. In one of the previous talks I delivered about the book, I also said that the first time I heard about machine learning or microcontrollers was, well, I would say more than 8 years ago. But it wasn't TinyML for this reason, because, well, machine learning, definitely it wasn't like what we have now with convolutional networks, for example. But at the same time, embedded programming, it wasn't like this. I mean, I still remember at uni, at least 8 years ago, we were still using assembly just for turning on and off an LED. And now with Python, you can run machine learning. And that is the reason now it's TinyML. But in the past, we would talk about machine learning or microcontrollers. But now it's definitely TinyML because it's extremely easy for everyone. So it's a very, very cool demo, Alessandro.
Yeah, I mean, I didn't do much work on it, so I'll just, I'm just the kind of the shower rather than the builder here. But it is a really cool demo, and I think it does show how things are moving really fast, right? I think there are from my perspective, there are multiple things at play here. Obviously, there is more powerful computing platforms that enable more to happen on these computing platforms, but also new tools like Edge Impulse, for example. But also, I think what's really interesting is that there hasn't been a lot of development around new model architectures built for edge devices, right? And I think we're seeing now more of that, like specifically in this case, this new architecture for object detection, Fomo. And I'm really excited to see more of these models that have been taught for the edge, right, for these tiny devices, because I think that's where you get most of the speed ups. So I'd be really curious to see what happens in the next few months. But we're almost running out of time, so I wanted to make sure that we have one thing to do before we run out of time, and before I give the chance to all of you to say one last thing. We have a giveaway. So we have the ability to give out 3 books. We've announced this earlier, and I was about to forget. We've got the ability to give out 3 books to the first 3 people that write in the YouTube chat, because we're following the YouTube chat here. The first people that answer with what is their favorite project, a favorite TinyML project, and maybe share a link. If it's your project, share a link. If it's someone else's project, share a link as well. But share your favorite project, and we'll give you we'll be in touch, and we'll give you the link to the book. It will be an ebook just for ease of sharing it. But yeah, I'd be curious to hear your thoughts or your. So we've got iShotGR actually with my baby monitor. So this was actually one of the first projects that I saw. I think it was your first project, iShotGR, on TinyML. And yeah, thank you for sharing that. It was a really cool project. We've got Peter Hill saying that he's interested and excited about vision systems and object analysis. Really cool. Actually, I'd love to get your maybe another comment on what kind of use case you're thinking specific, if there's any specific use case that you've got in mind. So iShotGR wants to be skipped because he's got a book already. So Gian Marco, he's got your book already. We've got someone else here, Gianpaolo Macario, finding labels on bottles. That's a really cool one. Awesome. So we've got 2 winners. We need one more. Any more takers here? Anybody else that has seen some cool projects?
Can I play? I'm kidding.
There we go. We got another one. Spelling the alphabet with a smartwatch. Thomas, that's an interesting one. Although is that really TinyML? I guess you could do a speech synthesizer with TinyML, perhaps.
One of the earliest TinyML projects I saw was recognizing characters written on a touchscreen.
Yeah.
So a smartwatch is like it's taking it down and putting it into a wearable.
Yeah. And this is actually another interesting one, measuring. I always forget what that stands for. VOC. It's what is it? Something
volatile organic compounds.
There you go.
Something like that.
There you go. So we got a few coming through. That's awesome. Thank you guys for for sharing. If you, I'm going to ask the winners if they could share, they could send an email to social@edgeimpulse.com. We'll send you the details for the book. So that's I'm going to just run through the winners quickly. Peter Hill, Gianpaolo, and Thomas. Thank you guys. Thank you for playing, and thank you all for being on the call. It was a really good AMA. I was really, I think we've covered quite a lot of stuff, quite a lot of ground, a lot of exciting stuff happening. I'm really curious to kind of get your last thoughts on where we're going. Like, what do you foresee in the next 6 months, a year? And also, perhaps if you've got any plugs you want to do in the last minute or so, anything you want to announce or share, feel free to do it now. So let's start again with Gian Marco.
Okay, so in the next year or so, I'd like to see more data sets for sure for TinyML, and more models for TinyML, in particular for doing also transfer learning. I believe for transfer learning, we have quite a lot of models, but not for TinyML. And for image recognition, would be desirable to have definitely more pre-trained models. In terms of use cases, well, a year probably is not too much, and probably also 5 years is not far away. But definitely with the probably micro MPUs, we are going to unlock new use cases for with camera models. So probably, as I mentioned earlier, something related to security with no internet connection to avoid, to have privacy and security with the device. So this is more or less what I see. I definitely hope to see more data set anyway for TinyML for playing with it, related to the sensors we have usually on board.
Awesome. We got a +1 on the book from ShotJR.
Thanks a lot.
Cool. Massimo, you're up next.
Well, so one thing that's a personal interest of mine, but this is just not speaking officially for Arduino, but one of the things I'm very passionate about is the whole, how do we get people to understand machine learning and then tiny machine learning? Because a lot of the materials that you see online, is it either the first page, it says machine learning is very easy, then you turn the page and there's a massive formula on it, or they are in a way they are focused on teaching you one framework, no? So there is this missing link, which is this part where you can explain, and I've done a little bit of that, and I'm very interested in figuring out more and more ways where you can take someone who is very smart but doesn't have the necessary math background and take them to the point that they can really understand what they're doing, which is kind of what we did with Arduino, but find a way to teach and explain this concept in a way that's understandable by a large audience.
I love that. And I love the fact that, with Arduino, you built the tools to enable domain experts to build products, right? Like without electronic products. And now we can do the same with machine learning. I think it's really cool to enable people to build useful things with technology. So really cool. And excited to see what to do more to explain to people how to use this stuff, right? I think it's really good. Cool. Alistair.
So I guess I want to pick up that point that Massimo made. The idea that even a year or two from now, that the majority of machine learning deployments will be made by the machine learning community is sort of laughable. I really want to see development of the tools to make machine learning more accessible to the average developer in the trenches, because right now machine learning community is very academic. It has an academic background. It comes from academia. There's a huge emphasis on training, on model suitability, that I don't think is applicable to the average developer. I mean, I think the average developer is going to be far more interested in how their inferencing is running rather than how the training is. So we have to make transfer learning, retraining models really easy for folks that don't have the background, that don't have the mathematical background, that they shouldn't need the mathematical background to do that. They shouldn't need to understand the machine learning at a low level because they're developers. They should be able to use it as a tool. And I hope over the next couple of years we'll see that. And an Edge Impulse is an obvious step towards that. And I think that's what my hope is for the next couple of years.
Yeah, I can completely agree with that. I think I completely think that developers should focus on the application rather than the maths, right? At the same time, we also, as Edge Impulse, our vision is to not really hide that stuff, right? Like we should enable developers, yes, to build stuff faster, but at the same time to understand what they're building. So I think it's important to, use tools that allow you to look at what gets built, right? Like a good example is, again, going back to Arduino, it was my first embedded programming tool that I've ever used, the Arduino IDE, obviously, and in the Arduino language. It's really cool that, you can, yes, it's made easier, it's wrapped, and, there's layers that abstract away the complexity, but actually you can look inside and you can still see, all the kind of embedded stuff that you don't, in most cases, you don't want to see, right? I think that's the right paradigm, and I love that approach. So I think hopefully we'll be able to kind of do more of that for the whole community, the whole TinyML community. Cool. And I mean, obviously we've talked about a lot of stuff, but don't forget to get a copy of your book. We've got a discount code for you. It's here. So go to this link, and if you haven't if you were one of the winners that won the book, the free book, you can get a book with a discount code. So I think it's 25% off, if I'm correct. So feel free to go to the link and use the discount code. Thank you all for participating. We've actually gone over by almost 10 minutes. So apologies to the ones of you that wanted to go somewhere else. But thank you so much for the time. Too many Italians, yes.
Too many Italians.
But thank you so much. Thank you, Massimo, Alistair, Gian Marco, for a great hour together, and for sharing your thoughts and your vision on TinyML. And thank you to the audience. Thank you, everyone, for attending.
Thanks a lot.
Thanks for having me.
Bye, everyone.
Bye-bye.